Cloud Speed is your gateway to AI and the cloud.
Welcome back to Cloud Speed. In today's project, we want to host an AI model on an EKS cluster. So previously, we had been able to host our AI model, specifically a full stack chatbot on an EKS cluster, but we didn't use GPU-enabled EC2 instances. So this time around, we want to see how having a GPU on our instance would improve the speed, the processing speed of our application. So in this particular series, what we do is that we try to create full stack applications from scratch using popular open source software like Streamlit, like Ollama, like FastAPI, like LangChain. So we use this bunch of softwares to create an easy to use, easy to create full stack application, usually an AI chatbot. You can check out the other videos we have in this series. So in this specific one, we are using on our node group, which are made up of two instances, we'll be using GPUs for our node group. Yeah, and we'll be hosting our chatbot application on an EKS cluster. In case you don't know, EKS is the AWS native Kubernetes managed hosting service. So it's easy to use to host your Kubernetes application on EKS. So let's just get started. So in this project, we'll follow, like we did for the other projects, we'll follow a documentation. So this documentation is available for everybody. I'll give the link to the repo of this project. The repo has the code base and the documentation. So you can access the repo. In the repo, you go to the /docs folder. That's where you see the documentation. You can access it from the description of this video. You see the link to the repo. So you can follow through. You can try to do this project on your own. So we'll follow through with my documentation. So let's get started. So what the first step we have here is to create an IAM role for our EKS cluster. So we'll name this role Amazon EKS or to cluster role. Then we need the policies for this cluster, which is the EKS or to Amazon EKS cluster policy and Amazon EKS service policy. So what we can do now is to go to AWS console, then we can create the role. So we'll follow through step by step. We'll check through our documentation to see what are the requirements for this role. You select EKS, then you select the specific use case for the EKS. So in this case, we use EKS or to cluster role. Okay, next we can add the permissions for our role. As you can see, permissions have been added to that specific use case we selected, which does not necessarily include the roles we need. So let's check out the roles we need, and then what we can do is we can as well create the role and then give it the appropriate name. Then we can later on add the permissions that we require. So our roles have been created. So click on the role again and go to permissions. You can see at the top left, you see add permissions. You click on that, you search on the permissions you need in this case. So I'll just paste it as I copied it and try to edit it. You see the permissions and then you click on add permissions. There are multiple ways you can do this. You don't necessarily have to do it where I did it, but just ensure for that specific role, Amazon EKS or to cluster role, you have the necessary permissions as listed in the documentation. Then next we create another role for our EKS node group. So what this does is that it gives our EKS node group the permissions it needs to access other AWS services. So in this case, we name this specific role Amazon EKS or to node role. Then we give it the permissions of Amazon EKS worker node policy, Amazon EKS CNI policy, Amazon EC2 container registry read only. So let's go ahead. Use this case, we select EKS and then we select EKS auto node for the use case. It doesn't have the necessary permissions. We can as well create it, give it the appropriate name. We create it and then click on the view node, the view role. You can copy the roles required and you add the required permissions manually. Yeah, we can copy the permissions required and then we add them manually. Okay, just keep pasting them, edit them, you check them, and then eventually, after checking all of them, you click on add permissions and you are good to go. So next on our documentation is to launch our EC2 instance. Okay, just to get this clear, we are launching this EC2 instance not for our EKS NodeGroup. The point of launching this EC2 instance is for us to be able to manage and access our cluster remotely. So we could as well as done this from you could have done this from the command line or PowerShell of your local computer, but I specifically don't want to install all of this on my local computer, so that's why I'm using an EC2 instance as well. And please also note that our EC2 instance in this case won't require us to create a GPU. It won't be using a GPU. So we'll go ahead and name our EC2 instance. We can simply name it access. In this case, we are not selecting any instance type. We use the free tier instance type. Then we create a key. The key pair allows us to access our instance securely. So what you can do is to name it cloud speed. Then we create the key pair. It will automatically be downloaded to your local computer. Okay, now you need to enable the security group. In this case, we enable HTTPS, HTTP, and SSH because we'll be connecting remotely from our S2 instance. Then we'll modify the storage to 20 gig. Okay, just ensure you are creating just one instance. Then we can go ahead and launch our EC2 instance. Okay, after launching, you click on your EC2 instance and you check the documentation to see what next you need to do. So the next step we need to do at this point is to copy the files from our local environment to our EC2 instance. So I told you previously that I created the repo for this particular project. So the repo contains the code base, which are the .yaml files, the actual Python files for FastAPIs, the Python files for LangChain, Python file for Streamlit, and the other softwares we'll be using in this case. So ensure you copy the files from your local computer or from the repo to your EC2 instance, like I'll do in this case. Okay, you can go ahead and check through all the files we have for this particular code base. Then what next we can do is to at least start running our commands to transfer the files from our local computer to our EC2 instance. So let's try to confirm that we have moved the key pair that we downloaded from AWS to the appropriate directory. In this case, you can see it. We have actually moved it to the right directory for us to use. So now you can paste your command. Please ensure you update the IP address of your command, else your connection will fail. So just go to the IP address and paste it, copy it from AWS and paste it. Okay, looks like we are connected and our files have been transferred successfully. So the next thing to do is to connect securely, which is to SSH to our EC2 instance. So in this case, we want to start running the commands we need at this point directly on our EC2 instance. So also ensure you update the IP address of this particular command to ensure you are connecting to the right EC2 instance, else your command will fail. So we have successfully connected to our EC2 instance. Now check on the documentation. The next thing here is to install the AWS CLI. So AWS CLI allows us to access AWS resources through the command line. So we will quickly run through these commands, this list of commands, without wasting much time to install AWS CLI. After installing AWS CLI, ensure you run AWS flag version to ensure you check and confirm that AWS CLI is actually installed on your computer. So the next thing to do is to configure our AWS CLI. So what we are actually doing with this command is to give our CLI a specific role or user, the necessary permissions they might use or they require to access our AWS services. You know, the cloud is all about permissions and access and authentication and authorization. So you want to ensure the least privilege for most cases for production use case, but might not necessarily be the case for this project because we have a specific goal and not necessarily the goal of ensuring least privilege in this case. So what our advice is to give your user as much permissions as it needs, because this is just a project, so you don't run into issues in the future. So you can give your IAM user as much permissions as it needs. Although what it really needs is permission to access EKS, permission to access AWS EC2, permissions to access EC2 instances or node groups or computes. So those are the necessary permissions it needs. For this particular case, I gave my user the permissions to access almost all AWS services. Then after the project, I had to delete this specific user to ensure security of my AWS account. Okay, you click on AWS configure. It will require you to put in the access key ID and the secret access key. So these are the details you actually get when creating your AWS IAM user. Okay, what next we need to do is to create our cluster. Obviously, the command for creating our cluster is really bulky, but I'll try to summarize the resources we'll be needing for this command. So we'll be needing the name of this particular cluster. In this case, we gave it DeepSeek, and then we'll be needing the role ARN. So we'll be using the auto cluster role which we created earlier. Then we'll be using the VPC config. In this case, it's just 3 subnets. The subnet ID is from 3 subnets from our VPC. So ensure you are using the right VPC. You know, each AWS region has a VPC. So know the region you are using and ensure you are using a subnet from that specific VPC. Then we'll also need the security group ID from at least one of our security group. So I'll show you how to get the security group of. So you can actually get the necessary details from your AWS account, which I'll show you now. You can actually get the details from your AWS account. So I'll try to go through this quickly. So in all you are doing, ensure you copy the right details and the figures or the data you copy are actually correct, because this particular process or this particular command is error prone. You don't want to go through running this command multiple times. It's very error prone. So you copy the IDs and then you update it directly on the documentation. Okay, it seems our cluster was created successfully. We had to do this just once without going through multiple tons of trying it out, and I'm so glad it worked. So for you, just ensure you copy the IDs correctly and you paste them at the right point, just like I did in this video, to avoid issues. Then next on our documentation, we create our ICRO repository. And you definitely want to ensure you are using the right version. Okay, then we go to the next command and post this. Yeah, it has been created successfully. So the next thing to do is to install Docker on our EC2 instance. So we'll be needing Docker at this point because we'll be building our image directly from this specific command line. So that's why we'll be needing Docker. After building our image, we'll have to push it to ACRO. So we'll quickly go through the commands for installing Docker. Okay, then Docker compose, confirm Docker compose is installed. Then we exit. Okay, log in back. Yeah, clear the screen. Clear the screen and we'll continue. Let's try to increase the text size of our command line so we'll see it better. Then the next thing for us to do is to build our image. So we simply need to say, okay, we'll go through this command quickly as well because it takes time to build the images. As you can see, the image for our Ollama Docker is about 1.73 gig, which is really large. And we'll build for FastAPI as well. Oh, that was an error. We'll build for FastAPI. Okay, let's build for FastAPI. Okay. The next thing to do is to tag our images because we want to reference our images through a tag. We can authenticate to AWS CLI before we can push the image to a CRO. So the command is here. Just ensure you use the appropriate ID for a CRO. Then confirm that you are using the correct region. Then now we can push our image to AWS CLI. So we'll run through this quickly. This definitely will take a lot of time. So we can push the image for FastAPI as well. Okay. All right, now we can verify that our images have been pushed to a CRO. We could have done this from the command line, but let's try to verify from the console as well. Okay. Oh, for our FastAPI, it's yet to complete, so I believe that's why it's not showing up. So we can go back. We can refresh it again to see that it has been pushed to FastAPI. Okay. So the next thing for you to do is to update your deployment files. I've updated it already on the code base, but I'll just try to go through it here again. So at least when you follow through with the projects, you remember to update it and you know exactly how to update it. I'll be using Nano in this case. You can as well use any other text editor for yourself, like Vim. It's okay, Nano. Ensure you update the image link or URI for your ECRO images. So the next thing to do is to install kubectl. So kubectl is the command line for Kubernetes. So you use kubectl to manage and to access your Kubernetes cluster. So we'll quickly run through installing kubectl in this case. You can follow through the commands which I gave in the documentation. So when you run the commands, it will know the after installing kubectl, you update your context. So when you run your commands, it will know the cluster it's going to reference. Then you can get your context to confirm it has been set appropriately. Okay, so the next thing to do is to create our node group. The node for your cluster, the actual machines where your application is running. This is where you need the GPUs, or at least you need to use a GPU-enabled EC2 instance. So in this case, we'll be using G5 extra large, which has an NVIDIA GPU. And from the documentation, it says that we need at least 20 gigabyte storage. Okay, let's try to access our cluster from our console. Then you go to the node group and create. This is where you create your node. We name it DeepSeek, and then we click on next. Okay, you select your AMI type. So previously, you select your AMI type. So originally, it will tend to select the free Amazon Linux 2023, but you cannot use that in this case. So as it was stated here, you have to select the Amazon Linux 2023 NVIDIA, which is stated there. Then the next thing is to select your capacity type, which should be on demand, which should be spot, which could be reserved instances. You can just search for quota at the top search bar. Then you select quota. I think I have it opened already. Then you search for EC2. Click on EC2. Then you go through. You search for G. So what you are trying to do now, you are trying to search for the G type instance to see if you have access to G type instance. Okay. From what you can see from my account, I have access to 4 vCPUs of G type sports instance. Then I have 32 vCPUs of G type on-demand instance. So for creating our NodeGroup in this case, I can create for 4 vCPUs, or I can create for 32 vCPUs, but I have for both spot instances and for on-demand instances. So when creating for spot instance, I cannot go more than 4 vCPUs, else the instance creation will fail. So when you do this, what you can do is to actually check if you have access to G-type instance, whether spot or whether on demand. And most cases, you won't have access to G-type instance, whether spot or on demand. What you can also do at this point is to go to AWS support, and you can request access to G-type instances. You can request for either spot, or you can request for either on demand G-type instances. I have done the request already. I requested for both spots and I requested for both on demand instances. So I was granted access. I actually made a video that shows you how you can request for G-type EC2 instances. So what else we can do is to at least let's confirm that this instance type request is only limited to the specific region which you requested your instance type for. So in this case, I'm using US East 2. So let's try for US East 1. Okay, as you can see, I don't have access to G type, whether spot or whether on demand, for US East 1. So in your case, when you want to request access to these instances, ensure you are using the right region, else you won't have access to the instance type for the correct region, and that might become an issue. Okay, let's close that. So I can select on demand in this case because I'll be using more than 4 vCPUs. From the documentation, we need at least 20 gigabytes of storage. Then for desired capacity, we are just trying an AI application, so we don't need much capacity. And also note that GPU enabled instances are actually higher in prices compared to the regular EC2 instances. So we'll leave majority of the other settings as it is. Okay, we'll add a subnet. We'll just add the 3 default subnets, and then next we can. So let's confirm our settings, and we can create our nodes. The next thing is to confirm that our nodes have been created. So I clear the screen, and okay, it seems like the nodes have not been created. We just need to wait a little bit. So let's refresh. Still creating. Okay, we can wait a little bit, and I'll just pause the video and come back when it has fully created. The next thing for us to do is to install the NVIDIA GPU device plugin. The purpose of the NVIDIA GPU device plugin is it's a daemon set on all nodes in the cluster that have NVIDIA GPUs. So this plugin allows Kubernetes to detect and manage NVIDIA GPUs as allocated resources for scheduling workloads. So next we verify the GPU availability. So this checks that GPUs are being recognized by Kubernetes, else we might just be running our AI models on Kubernetes and not necessarily making use of the GPUs. Then the next thing is to create our service account for Traefik. So we'll name it Traefik XA. This service account will be used by Traefik Ingress Controller to access cluster resources securely. So these are essentials for using advanced Traefik features on Kubernetes, because at this point now we'll be using a specific domain name, and we'll be connecting, rather accessing our domain through a secure connection, HTTPS in this case. So let's verify that the CRUDs were successfully installed. Okay. Then next we can apply a default storage class. So the default storage class is used by Kubernetes to provision persistent volumes for pods automatically. So when running through this command, please ensure you follow through the command appropriately and in the steps in which it is given on this documentation. So after this, you can get your Traefik external IP. So let's try it out. As you know, when you create a Kubernetes cluster and you request a load balancer port, so you'll be given a load balancer IP DNS by your cloud provider. So that is what we just requested to see. And in this case, it's connected to our Traefik ingress. So what we can do now is to confirm or to check the IP address associated with our load balancer DNS. Okay, so let's try to, this is our command prompt. Let's try to increase the font of our command prompt so we can see the details clearly. Okay, so now we can see the IP address associated with our load balancer. So what we need to do now is to update our DNS, rather our domain name. In this case, we'll take the IP address of our load balancer and then we'll update it on the value of our root domain name. I'll click on save, and then yeah, it has successfully updated. So let's try to see if it will reflect. Note that I'm using this specific DNS name. You will definitely be using yours, so ensure you make the necessary changes. Okay, it has not propagated yet, so you can give it a little bit of time to propagate. We'll pause the video and we'll try it later. It's here to propagate. All right, so the reason we see FastAPI is running here is because we are trying to access the route of our API. So if we really want to communicate with our model or our AI model, so we'll go to the /generate route. So that's where we can actually communicate with our AI model. So we see that in the documentation. Okay, so let's try to pass an input to our AI model. So we'll go to the /generate route. Okay, yeah, we got an output from our model. As you can see, we are using a thinking model. That's why you can see the markup think on the response. So it responded, we put in say I, and then it responded, hello, how can I assist? So this file, the app.py, is what creates our front end. It creates a simple interface through Streamlit that allows us to send text messages to our API endpoints through our LangChain application. So now we can start our front end application. So we do that by running Streamlit run.app.py, and yeah, it's currently setting up. All right. So this is our simple interface. Let's just give it a simple prompt. We say hello. Okay, it successfully responded. Hello, how can I help you? I urge you to check out the previous videos where we didn't use GPU enabled EC2 instances. So we can also give it another prompt, and it's still also fast. All right, you can go through multiple rounds of giving it prompts and then seeing the response you get. Okay, the next for our documentation is for us to confirm that our application is actually using our GPU in situ instance. We'll check out the metrics of our GPU as we prompt our AI model, just to ensure that the model is actually running while we observe the metrics of our GPU. Alright, so we give it a text, then we go back to our command line, which is still actually connected to our S2 instance. Then we can run the simple command. Okay, we can see the metrics, and let's focus on the power at least. So you can see initially the power was about 42 watts, and then it has reduced, which indicates that our model has finished running through our prompt or finished responding to our prompt. At least this confirms that our AI model is actually using our GPU. So it's responded quite well. So we expect it to give us lots of text relating to the event. So we can now fully confirm or see the metrics as the metrics reduces over time when it finally gives us the detail or the story we are looking for. So you see how the power actually increased and decreased over time when our models was trying to generate response. And we can exit our command line. Okay, we can as well exit our application. So the next thing for us is to delete our resources. And I want you to delete your GPU EC2 instance, your EC2 instance, your EKS cluster, because these things are costly. You will be charged for it if you don't delete them on time. Thank you for following through this project with me and the other projects we have in this series. Please drop your comments and like the video. Also, subscribe to our channel so you receive more updates when we post videos like this.
CloudSpeed is your gateway to AI and the cloud. We make videos showing you the latest in tech, and we break down the real-world use cases. If you found this helpful, hit that subscribe button and tap the bell icon so you don't miss any updates. Thanks for watching.